All right, welcome back everybody, and here is part 2 of our 8A lesson, and we're going to lead off with an interesting question here. Is the empty set a subset of any set? And the answer is yes, it certainly is. I want you to think about the idea of an ice cream sundae. I mean, no, maybe cold right now, at least it is the date I recorded this video. And you could certainly have a whole bunch of toppings on your ice cream sundae if you wanted, or you could just go with none of them and it's a dish of ice cream. So if your set is the set of all the toppings you could put on ice cream and you just decide, no, I don't want any, that could be an empty set. So it is possible that an empty set is a subset. Consider the set of A being 1 and 2 and B being 3, 4, and 5. Well, if I want all the subsets, and that's what pretty much this particular statement means, all sets X, such that X is a subset of A, then you want all of the subsets, not this, but the subsets. Okay, well, you could just pick one out of set A. You could just pick two out of set A. You could also pick 1 and 2. Every set is a subset of itself. Or you could pick none of them. And by my count, that's 4. That's 4 different choices of subset for A. Okay? So for B, we could kind of do the same thing. We could pick 3 individually. We could pick 4 individually. We could pick 5 individually, and each of those would be a subset. We could also pick 3 and 4 and leave out 5. We could pick out 3 and 5 and not include 4. Or we could pick 4 and 5 and not include 3. Another couple of options we have here, once again, you could choose all of those elements, 3, 4, and 5, or you could choose none of them. And by my count, that's a total of 8. So an interesting little thing, if I had only one element, let's kind of back up and talk about set C, which only has just the one element of 1 in it. Well, your two choices for subset are either it's a 1 or it's an empty set. So that would be 2 subsets of set C. So you notice that for every element that we add on, we're doubling the number of subsets. So what does that mean? In general, a set of K elements has how many subsets? It has 2 to the K. So if you get hit with this question and the practice problems are on an assessment or anything, how many subsets is usually how it's going to be phrased here. So how many subsets? You're just going to apply that particular formula of 2 to the K. So if they had 6 elements, then there are 2 to the 6th, and if you grabbed your calculator and powered that out, that would be 64 subsets. Okay? That's pretty easy to do. I mean, so it's kind of a fun little concept. All right, now just kind of moving on here to the last part of this lesson. There's a couple of operations that you can do with sets, and I want you to think particularly about these two operations, starting with this one, which looks like an N or an upside down horseshoe here, and that means intersection. So if I want the intersection of two sets, then that means I want the elements in both. Okay, so let's kind of say, for example, that A has the elements of 1, 2, and 3, and B has the elements of 2, 3, and 4. Okay, well, if I want the intersection of A and B, if I want the intersection of those two sets, I'm looking for the elements that are in both sets. Well, 1 is not in both sets, it's only in A. And 4 is not in both sets because it's only in B. But 2 and 3 are definitely in both A and B. So therefore, they're going to be in the intersection. Another way to think about this is consider University Avenue and LA Grant Parkway, where the traffic light is right outside the high school. Okay, well, that's an intersection because pavement from both streets is in the middle of that intersection. If you stop and think about it, it makes a lot of sense. And then this other operation here with the U, or the upside down of the intersection symbol, this is called a union. And this is elements in either set. Elements in either set. Okay? So if I wanted to find the union of A and B from these two sets above, well, then I just have to list out all the elements that are in both sets, but they could be in either set. So this time I'm going to include 1. I'm going to include 2 and 3 because they're in both sets. And I'm definitely going to include 4 because it's also in either A or B. So the word or is a little bit more inclusive here. And I'm going to throw that in there because that's a word that's going to come up again and again. With intersection, the word is and it's a little bit more exclusive. That means it's only going to apply to certain elements as opposed to all of them. And the or is going to, hey, everybody come along for the ride, let's go. Think about joke about a union. Think about a marriage, for example. When two people get married, each spouse is bringing in more family, so the family gets bigger. If you want to stop and think about that for just a second, in that context, it's kind of fun to use real-world examples of what that means in different contexts. So we've got these different sets here, and we're going to work through these examples real fast. And the universal set is the numbers 1 through 12, and A is the odd numbers from 1 through 12, so 1, 3, 5, 7, 9, 11. B looks to be just multiples of 3 that are in the universal set, and C is just the first 5 numbers. So if I want the union of A and B, then that means I have to take these two sets and put them together. I've sort of got to add them together almost, because it doesn't matter if the element is in A or it's in B. As long as it's in at least one of them, then it's going to be in the union. So 1 is there, 3 is there, 5 is there, 6 is there because it's in set B, 7 is there, 9 is there, 11 is there, 12 is there. So the only repeat elements were 3 and 9, so I just didn't write them a second time, and you don't need to do that, as you noticed with my example up above. Okay, pretty easy to do. If I wanted the intersection of A and C, then I'm looking for the elements that are in A and C both. And those elements you can quickly discern are 1, 3, and 5. Because they are the only elements that appear in both A and in C. Alright, you remember this little symbol from the last video. This is a complement symbol, which means I want everything that's in the universal set that is not in set A. So set A contains all the odd numbers, and if this is my universal set U up here, then everything that's in the complement will have to be the even numbers. So we're looking at 2, 4, 6, 8, 10, 12. Those are in the complement. Okay, so hopefully those 3 examples are pretty easy for you to follow along. These next 2 are a little bit more challenging because they require you to sort of follow an order of operations. You notice there's some parentheses here where it wants you to do the union of A and B. And then on the outside there's this complement symbol. So basically what this means is we're going to do the union of A and B first, and then we're going to take its complement. Well, lucky for us, we've already done the union up here, so we don't have to worry too much about reinventing this answer. What I am concerned about is the elements that are not in the union, but they are in the universal set. So I've already got the union, so I'm just going to take the things that are not in the union that I know are in the universal set. So 2 and 4 and 8 and 10 are the 4 elements that are not in the union of A and B. And then this last example right here has us take the intersection or the union of A and B and intersect it with C's complement. Okay, so this is where things get a little crazy here. We already know what the union of A and B is, but C's complement might prove to be a little elusive, at least right now, until we stop and work it through. So if this is set C, then C's complement has 6, 7, 8, 9, 10, 11, and 12. And the reason why I know this is because these are all the elements that are in the universal set that aren't in C. So that's C's complement. So now this is where things get a little hairy because you're not sure which one to do. Well, ultimately, you're really doing an intersection here. So if you're doing an intersection, then that means you're looking for the things that are in both the union and the complement of C. So I'm going to look to examine that and see if I can figure out which are in both the union and the complement of C. Well, the 6 is going to be in both for sure. And it looks like 7 is going to be in both of them. And it also looks like 9 is going to be in both of them. 10 is not in the union, so I can't use that. But 11 and 12 certainly are. And those 5 elements comprise the set of the intersection of the union of A and B and the complement of C. That's quite a mouthful to think about. So, good examples here. Go try the practice problems and good luck with them. And let me know if you need anything else.